All right, so yeah, this is a video just going over real quick how this demo is built, how it's assembled, and just sort of a thought and word dump. Um, Putting this together pretty hastily. Everything's kind of a disarray in this room, so I'm sure I'm gonna be panning around. You're gonna see sort of a mess. I apologize about that in advance. Yeah, so I guess just to start, there's three types of fasteners. I guess this video is going to cover a lot about fasteners because I didn't really touch on that in the bill of materials. And the fasteners aren't included in CAD, so I figured I should do sort of a deeper dive on that. There are three fasteners used in this build. The main one is the quarter 20 button head socket that requires a 532 Allen key for that. Those are used a lot for most of the structural connections. Then we have this Allen included in a little kit that I'm leaving with the demos. This is 9/64. This is exclusively for the shaft collar on the frequency response demo. We'll get to that in a second. And then this is a 3mm Allen key that's used for these M5 fasteners, which are also used on the frequency response demo. And then a little screwdriver for these smaller connections, which often use some kind of M3 fastener from this kit here, which those will generally have a nut at the end of them. Okay, so what we have in front of us here is the drive base. So that's part number SDoF-A01. It looks like this. Some differences from the CAD model. I think the only thing is that on this one, I believe in CAD there's 4 bolts constraining the this crankshaft bracket here to the base plate, but in real life there's 3. Maybe I did put in 3, I kind of forget, but just in case. Shouldn't make that much of a difference. One thing I do want to go over is how to tension the belts here and how the belt tensioning system works. So you would be tensioning this to swap the belt or swap this pulley here, or if you were just disassembling the whole thing. So the way it works is this whole like motor setup here, like all the drive electronics are attached to this bracket, which rotates about this dowel pin in the which is sort of a loose slip into the base here, and then to constrain it from rotating, there's this bolt on the backside. So to loosen this thing, you just go in with your Allen key. Let's put this back up here and go at it like so. And then you can see this whole assembly now is free to pivot about this little dowel, which is press fit into the base here. So it can rotate like this. So in this way, because the pivot and the motor, they're not collinear here, that gives you ability to tune this belt tension based on this. So when I was building this, I drilled and pressed this pin, and I built this bracket, and I put them together, and then I just cranked the motor as far over as I could, and then I just match drilled all the way through to create that tension spot, and then tapped this piece here and put this bolt in from the bottom. So with this untensioned, you can then pull this belt off if you were to undo this bracket that the whole motor is mounted to here. So there's a bolt here. There's a bolt on the other side. Originally I designed this to have 4 bolts holding this whole upper bracket to this lower bracket, but once I designed the H-bridge mounting infrastructure, that like sort of blocked certain holes from getting access. So let's see, in reality you have 3. You've got 3 bolts, and one of those holes is empty because there's no way to get a tool in to tighten that one. But that's been working just fine. Yeah. While we're on that subject, going over the wiring here. On underneath this little cover. So if you were to build another one of these things, this is sort of a tricky aspect of it. You can undo these covers. These are M3s. So a common theme with these M3 little spots, mostly used on for mounting electronics, and a lot of them, if they're interfacing with a 3D printed part, I will have super glued a nut into the backside or to a little recess of whatever 3D printed component this is interfacing with. Let's see if we can slide this cover off here. See if we can't get this one all the way undone without pulling out the pliers. I think I'm gonna have to get the pliers out. A pair of pliers is handy for this particular bolt because there's two different nuts on it in the stack up. Sort of doesn't make sense now. We'll get a look at that. Let's see if we can get this off here. There we go. Okay, and then we can take this off the rest of the way. It's a long one. All right. So there we are. Yeah, let's get a look at that wiring. Let's bring my light down here so you can get a better look at that. So yeah, this main cable here that I have in this cable ties ends in is terminated in a JST over there. It's just an old USB cord. I haven't had 4 wires running through it, so I hacked off the ends, stripped them. You can see I have that soldered to the female barrel jack, and then down there to the back side of the PWM input pins there. So white and green are PWM inputs, one for spinning the motor in clockwise, the other for counterclockwise. And then that black is a ground. You can see kind of in there's a second lead going from the barrel jack ground to the ground of the PWM. And so all these things will run off to this connector over here, which is an SM JST connector. So it's modular. You can plug in whatever modules you want. So black and red feed out 5 volts to the microcontroller, and then white and green are the PWM signals back. All right, let's put this light back up here. Okay. All right, anyway, back to the belt tensioning. So you it's a little tricky, but like with one hand, you can sort of provide this tension like this. And with the other hand, you can get that fastener back here. Just get it in by hand. Oops. See on that dowel pin first, and then yeah, make sure get that thread started, and then just give that a tighten the rest of the way. Yeah, there we go. Once it's cranked, it holds on pretty good. All right, so that's that. That's the drive base. Again, the fasteners, there's that one underneath. There's the 3 here that hold this bracket on the back side. You also have this guy that holds the crankshaft axle down. And then you have these two counter bore spots for M5s, and those are for installing the frequency demo. So we'll go over that next. Or I guess, yeah, right. And real quick, you have those two bolts there that are exposed. Then if you were to remove this bracket and that bracket, you'd be able to expose a third bolt underneath there that holds this upper bracket for the motor onto the pivot for the belt tensioning. And then this motor is bolted to this top bracket with a couple of 1032s, I believe. But you shouldn't have to be messing with that. We also have these. These are like the little cable management system. Those are also the quarter 20 stuff. I try to use these wherever possible. Yeah. Okay. Moving on to the frequency demo. So the demos I sort of keep attached in their little sub-assemblies. So here we have the frequency response sub-assembly, which is the spring and damper, the two platforms that ride on this linear rail here. And it's on a cam system, so you can actually like adjust the distance between the wheels and the track, so you can eliminate any slop in the system. Just check out a YouTube video on if you just look up like gantry plate, V slot, wheel, CNC, open builds. That string keyword should probably get you to the right spot. Again, this is assembled. You see these little spacers here? Those are so that you can use the same length of screw there without having to chop it, so they don't foul the wheels underneath. That's all those are for. And then these are those M3s from before on both sides, using nuts on the back side. So you can undo those and replace them pretty straightforward way. The reason why I have these little 3D printed spots, these little 3D printed guys here, is they prevent the spring ends from rotating in this direction when they're cranked, at least when the bolts are cranked. Because I was having some issues with that before, because then the spring was wanting to deform out like this instead of compress in on itself. Let's see what else. Oh yeah, so the modifications that I did to this piece from the kit is I tapped the center hole here, and then I also tapped these two holes underneath so that I could thread those machine screws directly into the gantry plate. So if you want to build another one of these, you'll have to tap those quarter 20. And the hole size nominally, you didn't have to drill it out at all. Just went straight in with the tap to like pulled this plate out of the bag and went right in with the quarter 20 tap. And that's been holding up pretty good. Yeah. And then there's a little spacer under here for this guy. Yeah, so then to attach this to here, there's three things you got to do. One is you got to attach this up here, and then you have to put the two spacers that go in these two center holes. So those are the M5s. So you have these like little aluminum blocks like this. These are the spacers with the M5s. You got one there, and I think another one is was on the backside of this guy's. Must have fallen off on the floor. Here's the other one. And you can see these have T-nuts, and these T-nuts slide in the into the track here. So the best way to do this I found is take the T-nuts off first. Set those aside. I got my cool little Radio Flyer mini wagon parts container. Flip this back over. Put that in from the bottom, slide on a spacer. Put on this T-nut like so. Ooh, if I can get that with my left hand. There we go. And just go a couple of threads, a couple turns. And the next guy, oops, that doesn't work like that. From here, that through. That's on other T-nut. Like that. Okay, cool. And then we can flip this back over so it's like this. And then you can just sort of slide the rail over the T-nut like this. Just make sure it's engaged. Let's see here. There we go. Better shot of that. You can just sort of slide that over, and then we'll go to this next one here. Oop. Just like that. Send this on there kind of loosely, then just flip this whole thing back over. You just put this as far over as you want. Just don't want to, make sure you don't foul the belt or the pulley with this end. Flip this back over, grab our 3mm Allen, and crank up those bolts there. And so those bolts, they came at some nominal size from the hardware store, but I did need to like cut them down so that they wouldn't be too long and poke into the rod here. So if you build another one of those, you're gonna need to cut those bolts down. Yeah, so then it's on there pretty sturdy. So the next thing is to get this into frame here, is to get the little crank onto the crankshaft. And so for that, we'll remove this. This bolt here is for retaining the pulley that's used in the other demo. And this needs to go up and over, so I'll just pop off this here. And this is just tapped directly into it, so this bolt goes right in. So we put this on first, just right on top. Go in from the back side here and just make sure that the axle isn't falling through. And then there's a little set screw right there, you can see it. That's where the 9/64 comes in. This guy, the bigger of the two Allen wrenches. So you're just gonna wanna get in and crank that. Actually, for safekeeping and for making sure that axle doesn't fall out, you can just throw on this fastener. One thing with these, whenever there's a hex axle, they're always retained at the ends with these bolts, and then a washer with the 1/4-inch bore. So yeah. Actually, wait, you definitely can't do that because you'll foul the crank. So you do not want to have this in. Sorry, do not have this in. Actually, we can do a quick demo as to why you don't have that in. So you put this on. Be careful. There's a very small spacer underneath this bolt, which looks like this. Let's see that. Let's install this, and because there's 3 holes, that means you can adjust the amplitude. So obviously the hole that's farthest away from the center of rotation there gives you the largest amplitude input. All right, so if this is here like this, and we have this guy in the middle, there's not enough vertical clearance, so the crank will bottom out on that washer. See, just it hits. So that'd be a bad idea. You definitely blow a fuse if you ran it with that. So do not run it with this retaining thing in. And this little horn thing is a shaft collar that I got from McMaster, and then I found a piece of steel, something like this grabbed in, and I welded this chunk to it, and then I shaped it to size to look like a servo horn, and then drilled and tapped those holes in the top. Okay, cool. So yeah, that's the mechanical setup for this guy. And then, I guess one last thing is I'll leave the cover of this off for now, just so you can see it. That organizer here. We want the frequency sweep module. So that's this one. This is the frequency module. It's just the potentiometer with a knob. There's an Arduino in here that turns the knob into a PWM. So you want to just connect that straight to the little cable there, which works real nice. And this way you can make any number of modules. because all the Arduino is going to do is you just need to power it, so it needs power in for PWM, or power in to just drive the Arduino, and then it runs delivers PWM out, and then that just bolts up over here. One thing though is I changed the design. This is like a first iteration print on the frequency module here. I made the whole thing. I gave it a different hole pattern. So as it is, the one that comes out of the box as of January 1st or whatever, what's today's date? January 10th, 2024. The holes don't line up because of a design revisioning issue. But CAD is correct. CAD is all up to date. So if you were to preprint the one from CAD, it would line up with these holes. So you can only get 1 volt in there. But yeah, that's that. That's the whole assembly done for the frequency suite demo. And now I'll just show you how to use it. So to use it, you pull out your power module, which is this guy, which is the 12 volt power supply that I've attached as a DC-DC 12 volt to 5 volt, convert to a barrel jack on there to power the microcontroller. It's got this inline fuse here with blade fuses, automotive blade fuses, to protect the system from breaking itself too bad. And then it's an XT60 connector and an on-off toggle switch. So the on-off toggle switch doesn't actually control the microcontroller, the output of the DC-DC. It just controls, it's just in line with the motor power. So this cuts motor power, but not microcontroller power. Let's see, actually, I'll just set this up over here. No, it's gotta be behind. Just plug this into any wall outlet. Actually, yeah, real quick, it's just this kind of plug. I bought it at a hardware store. When it's plugged in, you know it's on because that little fan will be whirring. And there's a little green LED in there that turns on, you can see. Yeah, I just want to make sure that that thing is off. And then you plug in the barrel jack. I'll also unplug this. Make sure this knob is all the way cranked down to the left to make sure that it won't just start going crazy the instant you plug it in. So I'll unplug this so it won't go crazy. I'll plug this in first. It doesn't really matter the order. That just pops in right there. And then this XT60 pops in right here. And you can see that when we turn this switch on, we get a little indicator light on our H-bridge, so everything's good to go. Nothing's gone crazy. Also, that indicator light means that the fuse is good. Yeah, and now we'll just gingerly plug this in over here, and it should be good to go. And then you just give this a little turn, and voila, everything works great. Cool.